It gives good morning, good afternoon to one and all. It gives me an immense pleasure to extend a warm and cordial welcome to everyone gathered here for Launchpad 2026 on the theme Human Robot Interaction Through Extended Reality, organized by SA Engineering College, an autonomous institution affiliated with Anna University. The college was established in 1998 by Dharmanayudu Educational and Charitable Trusts with the vision of providing quality and technical education. The institution is approved by the AICTE and is affiliated with Anna University Chennai. Recognition of its academic excellence and commitment to quality, UGC has conferred autonomous status on the institution from 2019. Most of the undergraduate programs offered by the institution are accredited by NBA. Currently, the college offers 11 undergraduate programs and 6 PG programs, catering to diverse fields of engineering and technology. At this juncture, I would like to express my heartfelt gratitude to our respected management, trustees, our principal, and all faculty members for their unwavering support, guidance, and dedicated efforts in making this event a grand success. It is now my privilege to introduce our distinguished speaker for today's session. Mr. Rajsekhar is a mechanical engineer, robotics researcher, and inventor. He is currently pursuing his PhD at the HIVE Lab, Department of Design, Indian Institute of Technology, Kanpur. He earned his bachelor's degree in mechanical engineering from Adiparashakti Engineering College, affiliated with Anna University, and completed his master's degree in advanced manufacturing technology from Shastra University. Prior to commencing his doctoral research, he contributed significantly to research and innovation at the TCS Robotics Innovation Lab, the IIIT Hyderabad Robotics Research Center, and the Indian Institute of Science, Bangalore. His research interests include mechanism design for robots, physical AI, extended reality, and human-robot interaction. He is the holder of granted Indian and United States patents in the field of robotics and has authored more than 50 peer-reviewed research papers and technical articles published in reputed journals, conferences, and magazines. We are indeed honored to have such an accomplished researcher and innovator with us today. I am confident that his insights into human-robot interaction through extended reality will inspire and enrich all of us. Once again, I extend a warm welcome to our esteemed speaker and to everyone present. I wish you all an informative, engaging, and successful session. Thank you. Rajsekhar, you can start the session.
Yeah, thank you, Professor Danish, for the kind introduction. I think the screen is visible.
Yes, it is visible.
Yeah. A very good afternoon to everyone. This is V.S. Rajsekhar, a PhD scholar at the HIVE Lab of Department of Design, Indian Institute of Technology, Kanpur. Today, we are going to look into a topic called human-robot interaction through extended reality. I think many of them would have come across the term human-robot interaction, but extended reality may be a new terminology for you, which we will be dealing with in detail in today's session. A short introduction about me. I did my schooling at Balalok Matriculation High Secondary School in Chennai, bachelor's from Adiparashakti Engineering College, affiliated to Anna University, master's from Shastra University, Tanjavur, and I'm pursuing my doctoral degree at Indian Institute of Technology, that is IIT Kanpur. I have worked at Tata Consultancy Services, IIIT Hyderabad Robotic Research Center, and TAL Manufacturing Solutions Limited, and Indian Institute of Science, Bangalore. My area of interest is centered at snake robots, where I focus on bio-inspired gates, computer-aided multi-body dynamic analysis, modular robotics, extended reality, locomotion control, mechanism design, robokinematics, and human-robot interaction. My current focus during the PhD is in the area of disaster management, where I create awareness, evacuation, and rescue through extended reality by conducting user survey. These are few of the robots that I have built in the past 15 years. This ranges from snake robots to aerial robots and manipulators. Now let's dive into today's session. Today we'll be seeing the elements of human-robot interaction, which is shortly called as HRI, through extended reality, which is shortly called as XR. the elements of XR, that is elements of extended reality, their applications, a few topics in mathematics, and the case study about how to control a robot through extended reality. Now we'll look into the elements of human-robot interaction through extended reality. We'll be dealing with individual elements, that is humans, robots, interaction, and extended reality. We will try to understand who a human is. Humans are, in general, differ based on their gender, differ based on their special capabilities, and differ based on their age group. They range from infants to old age. In between them, there are teenagers, young adults in between them. For example, a smartphone is a technology which was successful because it was able to understand the needs of all the people of all age groups, and it is useful for all people. In the similar way, that the technology which we design using human robot interaction should be useful for people of all age group. This should be there in our mind when we design the robots for humans. Robots. So in this slide, you can see the robots which are made by me in the past few years. This is a quadruped robot, which is a four-legged walking robot. These are a graphical representation of a robotic manipulator. This is an aerial robot, a drone which has a gripper at the bottom, which carries a box along with it. This is a snake robot, which moves on a planar surface. This is also a snake robot which moves inside pipes. This is a snake robot which is half hybrid. It's a hybrid robot, half rigid and half soft. So these robots can be controlled using extended reality. In interaction, if you see, the humans and the robots have to interact. So this interaction can be physical, that is by directly humans touching the robot, or through gestures by asking it to stop or start using our fingers and our hands, or it can be through voice and gaze controllers by which you can control the robot. It can be through environmental and spatial interaction. It can be through multimodal. Multimodal here means it can be a combination of physical, gesture, and voice. And it can be through collaborative means by using several sensors, or it can be autonomous or instruction-based control. So this is how the interaction happens between humans and the robot in reality. So now coming to the term, what is extended reality? Extended reality lies between two major terminologies called real environment and virtual environment. Here you can see a picture of a real environment where there is a building and grass on the floor. This is what we actually see in our real life. Virtual environment is something which is created synthetic on a computer using computer-aided design software. So in between them, there are a lot of realities called as phenomenal reality, augmented reality, diminished reality, mixed reality, annexing reality, augmented virtuality, and virtual reality. We will be dealing with them in detail in the upcoming slides. So if we are able to control the robot using one of the 7, 1, 2, 3, 4, 5, 6, and 7 types of realities, then it is called as extended reality. You're controlling the robot through extended reality. So the extended reality, like a computer, has hardware and software. So here, if you see, there are multiple televisions in front of the user. The user interacts with the sensors which are over here, which means that this is a cave kind of setup. Also here, there are kids who enjoy the actions which are captured by the sensors and displayed on the screen. So this is also a cave kind of setup. So this is a BCI, brain computer interface. So this reads the signals from the brain, and based on this, it will help you in controlling the robo. This is a Apple Vision. This is MetaQuest 3 headset where you can see the virtual environment inside it. And this is a LED fan. So there are LED lights over here, and this rotates over here, which gives an impression that there is something called Hive Lab when it rotates. So this is called a LED fan. Coming to the software, this is called Unity, which is mostly used for creating the 3D environment, and also Unreal Engine, which are used in most of the cases to create environments which can be virtual in nature. So the XR experience, that is the extended reality experience, is given by focusing on a particular software, creating the environment, and projecting this environment by clicking the play button over here so that it is connected to the headset which I am wearing, and I can control the environment using the joystick. Coming to the elements of extended reality, the first element is virtual reality. Now we'll move from the virtual environment to the real environment to understand how each reality contributes to human-robot interaction. So here, if you see, you can refer to the paper which is below for more details. This is the physical environment. Point cloud. A lot of points are taken and given colors to it so that a point cloud is created, and your virtual environment is created, and an interaction interface is created over here. So the person wears a VR headset, virtual reality headset, and uses the joystick or the handheld controllers to control the robo which is in the physical world. So this is through virtual reality. You're controlling a robo. Next comes augmented virtuality. So in augmented virtuality, what we try to do is we try to create a virtual environment and we try to project the real environment over it. So in this case, if you see the golden color foil which is on the robot, is a physical from the physical world. So it is projected on the virtual world so that we can understand how the robot is going to operate in a environment which is far away from it. This is called teleoperation study. Next comes annexing reality. So in annexing reality, what happens is we have physical objects in a particular shape and a person wears a headset and looks at that particular object. What happens over here is if a person holds this cylinder and he views something like a torch in the virtual world, so that he gets the feeling of that he is holding a torch in the virtual world. Also, he holds a white bottle in his hand over here, but he gets a hold of, he is holding a different bottle in the virtual world. So this is called, we are annexing it with some other virtual object in this scenario. So this is called annexing reality. Next comes mixed reality. In mixed reality, what happens is there are multiple robots which are controlled using a human interface. So 50% it is, if you see here, it is in the middle line. It is 50% real and 50% virtual. What happens here is the human is 50 wearing the headset and he is controlling the robots which are there in the physical world. So this is the interaction of the humans with the robots through the VR headsets. Next is diminished reality. The term diminished reality means that we are removing some unwanted object from the scene for better perception. So if you see the normal mode, there is a robotic manipulator. But this diminished reality removes that manipulator so that you can see the environment over here. So in some cases, you just need to show that there is a robot. For that, you can just draw an outline and show it on the screen. So this is diminished reality. Next comes augmented reality. Augmented reality, many of them would have come across. So in this case, the robo has to follow a path. The green color sphere with an arrow on the top shows the path which the robo has to follow. So this helps in understanding what the robo is capable of doing, and this helps the user to realize the path which the robot has to take. Next comes phenomenal reality, which is close to the real environment. If you see the picture on the left, I am operating a robo that is a spherical robo, black color, and an orange color hybrid snake robo in the using VR headset. But we do not know what is happening. The picture on the right shows there's a signal from the headset to the spherical robot. There's a signal from the headset to the snake robot, and in the physical world, the object which is present is viewed by the user in the virtual world. So this is what is represented by a picture. So this is what is the inner meaning of this picture on the left. The picture on the right outlines everything by adding extra information. So this is called phenomenal reality. Now coming to the applications of all these things, not specifically in the field of robots, in the field of reality. Application. We'll be seeing some applications which are related to agriculture, defense, design, healthcare, manufacturing, space, and disaster. In agriculture, we can use it by combining the view of the drone with the headset, or the augmented reality can be used to identify the damages which are created by the leaves which are highlighted on the screen. So this is called augmented reality. In defense, if you see, there is a virtual space where there is a virtual helicopter, and in the physical space, there's a physical helicopter. And this data is transferred from the physical world to the virtual space, and the information from the virtual space is computed and transferred back to the physical space. So this is the use, this is in short called as a digital twin. So it's a twin of the physical world in the digital space. Design. So in design, what we can do is we can have art galleries which people can explore by being at any part of the world. So you can have some paintings on the wall which people can explore, write about them in that area, and you can look into the suggestions given by other people, and you can conduct a virtual museum. Next comes healthcare. In the healthcare section, what happens is we can study the inner parts of the brain, for example, in this case, by controlling the direction of the plane which is over here. So that will help us in understanding what is present inside the head of a human in a more precise way. So this is very useful in healthcare division because most of the inner body parts, it is very difficult to explain by the professors. So extended reality can be used to explain these scenarios. So next is manufacturing. Manufacturing here, what is happening is thermal spraying. Thermal spraying means they're heating the element to some temperature so that it becomes hardened. So here a person raised the headset, he controls the robot's parameters, and the robot is in the virtual environment. It is getting controlled in the computer, and it transfers it back to the physical robot in the real environment. So this is very useful in manufacturing. Not only in thermal spraying, it is also useful in the assembly lines where cars are manufactured. And next comes space. So space is a zone which is being explored very much from the late 1950s. What happens here is, here there is a robot in space. We have a camera feed and we have a panel in the virtual world where we can control the robot by sitting on the earth so that the robot is operated in a far off place like Moon or Mars. So this is how extended reality helps us in conducting these experiments in disaster preparedness. So what happens is when a disaster happens, for example, in this case, earthquake, when a building collapses, people get trapped inside the building. What happens in this case is we need to give people a prior experience of how they will feel when they are trapped inside a building so that they do not feel afraid when they are trapped inside a real environment. So what happens here is the person wears the headset and in the virtual world, the building collapses. And this is what the person sees in the headset. There's an insect over here. There are some food items on the table. There's a robot which is coming to the rescue. There is water which is flowing through the pipe. So this is what the extended reality offers us to experience something which is unexpected. So for this, that disaster preparedness, it is very useful. So some topics in mathematics is important for understanding these terminologies. These include coordinate geometry, angles, vectors, transformations, probability, and graphs. In coordinate system, we try to identify and position in the objects in space. So if we see a chair over here and a chair over here, so what is the distance between them? So that has to be clearly mapped using coordinate geometry. Only then it can be projected properly on a mobile phone. And next is simple thing. It is trigonometry. A person wears a glass and looks at a pot. And what is the distance between the pot and the human's eye? That can be calculated by using a simple relationship, using sine, cos, or tan relationship based on the knowns and the unknowns. Vectors. If you see vectors, what happens in vectors is that there are robots which actually move from one place to the other on a flat surface. So this is the graph which you would see on a paper. So this, what happens here is the robot has to move 3 units over here and 2 units over here. It takes a short path in this direction. So this path is taken based on calculating the vector distance between these 2 points. Transformations. So this matrix, that is the rotation matrix, are rotation x theta, that is rotation of x about the axis. So this is z axis and this is y axis, and the x axis is coming out of the screen over from this point. So this is the matrix which you commonly see in textbooks to calculate the rotation matrix. So this is very simple. It might appear complex. It is very simple. So here you see a graph which is converted into trigonometric equations, and then it is converted into algebraic form, and then it is converted into matrices. So this is the beauty of mathematics, which flows from graph to matrices. So what happens here is there's a point P over here. So what happens in this part is that there is a point over here. So this is rotated by an angle theta. So this coordinate frame, this vertical frame is rotated through this. So what happens here is it is rotated by theta, which is represented over here. So what we need to do is we should calculate the entire distance between this point and this point so that we get the points distance. That is L1 minus L2. L1 is from here to here and L2 is from here to here. So the next is L3 plus L4. So this distance, vertical distance you need to calculate, which is calculated for PZ, which is L3 plus L4. So this, if you do some little bit of trigonometric calculations, you will get this equation. So what happens in this equation is that in the first equation, only Pn is there. So Pn column is 1, PO, PA is 0, 0. Next 2 things, Pn is 0, so these 2 are 0. And the next thing is cos theta. which just comes over here, minus sine theta, which comes over here. This sine theta comes over here, and this sine theta comes over here. And that Pn, Po, Pa comes over here. When you multiply this matrix, you will come back and you will get this equation. So in this equation, only this part is known as the rotation matrix. Okay, the next topic is probability. For example, a robot has to start here and it has to reach a goal here. There are obstacles over here. The probability of hitting the obstacle when it moves from this place to that place is 0.2, 0.3, and 0.4. When there is a probability of hitting it, the robot will always try to avoid that area and try to reach the goal. So this is the probabilistic heat map. This is 0.4, 0.3, and 0.2. So the robot here tries to go navigate in space where there is the probability is 0 and it reaches the goal point. So this probability plays a very important role in determining the path the robot takes to reach a goal. Next comes graph. So this graph is very important to understand because in 2D graph, and this is a 3D graph, a drone moves on a plane. As I explained earlier, wherever there is a probability of hitting, it doesn't go there. You should have played a game called Mine Swiper. So in that game, if you click on a button, it will say there is a probability of bomb exploding over one column next to the other and things like that. It is similar to that, but it is on a different scenario. So this in 2D, we call it pixel. In 3D, we call it voxel. In 3D space, a particular voxel has obstacles in it. So for example, when a drone is flying in a busy city, so there are a lot of buildings in the city through which the robot has to fly through. The drone has to fly through. So when it is flying through these kind of buildings, so the buildings become the obstacles and the probability of it hitting the building is so and so. So the drone tries to avoid the building and then fly to the goal point. So these are all some basic things, but there are some many advanced things which we have to perform for a successful path that a drone has to take while flying. Now let's move into a case study. So what happens here is, just a second. What happens here is we have a hybrid snake robot. So in this case study, what the purpose of this case study is that I'll be telling you how you can convert. I'm sure many of you would know how to build a robot, but once you build a robot, how to convert it into an extended reality platform where you can perform extended reality experiments. So if you see here, the part of the robot, the orange part of the robot is being 3D printed. So the 3D printer is printing the parts of the robot. This is the hot zone. The material comes from the top and it is being melted and it is being produced at the bottom. So this is a spherical robot and this is the interface where the robot is being used. So what happens here is we have a MetaQuest 3 headset. It is called MetaQuest 3, where it has two hand-held controllers. So once I wear this headset, I see something like this. If you see at the background, you can see the lab environment, but there is something projected on in front of me. So if you see here, I am using my joystick or the hand controller to control the icons which are present on the screen. So once I operate the robot, I just come out of the environment. You can see the person moving in the space. So this is how you experience the XR. So now I will show you a video where you can see how the robot is being controlled. Both the spherical and the snake robot is being controlled. I'm pressing the button on the screen where I'm wearing the headset. You can see the robot being lifting up its tail. Now I'm turning the other side where I'm controlling the spherical robo. So, coming to the conclusion, in today's session, we saw about the elements of human robot interaction through XR, the elements of XR, the applications, the topics in mathematics, and the case study. Thank you. I'll be open to take up questions.
Good afternoon, sir. Good afternoon, sir. What is the most existing project you have worked on at IIT Kanpur?
What is the
Most existing project you have worked on IIT Kanpur?
So one recent project which I worked on was this the robot which I showed you, the snake robot lifting up its tail and controlling the motion using VR headset. And before that, I had worked on some projects with this project where I created an experience for people how they will feel when they're trapped inside a building. Still, the rescue people come to rescue them. So this is what these are the two projects which I am showing today. But there are some other projects which you can find on my YouTube channel.
Thank you, sir.
Yeah. Thank you. Thank you. Yes.